Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Ethernet cabling is not limited to the common unshielded twisted pair. Several less common but equally important cable types appear on the exam and in real-world installations. These include shielded twisted pair, coaxial cable, and specialized cable jacket types such as plenum-rated cable. These types are used in high-interference areas, legacy systems, or in buildings where fire code compliance dictates material choice. Understanding their construction, use cases, and limitations is essential for answering hardware and networking questions correctly on the certification. Shielded twisted pair, also known as STP, is a variation of standard twisted pair cabling that includes an additional layer of shielding. This shielding may be wrapped around each individual pair of conductors or applied to the cable as a whole. The purpose of this design is to protect the signal from electromagnetic interference, which can come from nearby power lines, industrial equipment, or even fluorescent lights. Shielding helps ensure data integrity over longer runs or in challenging environments. Compared to unshielded twisted pair, shielded cable provides better noise rejection and improved performance in noisy environments. However, this comes at the cost of flexibility and ease of use. Shielded cables are typically thicker and stiffer, making them harder to route and terminate. Additionally, STP must be properly grounded to be effective. If the shielding is not connected to ground, it can reflect noise back into the signal path or act like an antenna, introducing even more problems instead of solving them. Shielded cabling is often used in environments with elevated electrical noise or where signal reliability is critical. These include manufacturing facilities with heavy machinery, data centers with dense cabling, or hospitals where medical equipment may produce electrical interference. Shielded cable may also be found in high-speed applications or areas with strict performance requirements. However, due to cost and installation complexity, it is not typically used in basic residential networks. Coaxial cable is another category of physical media that technicians are expected to recognize. Unlike twisted pair, coaxial cable uses a central conductor surrounded by an insulating layer, which is then wrapped in shielding and enclosed in an outer jacket. This layered structure provides excellent resistance to signal loss and external interference. Coaxial cable is widely used in cable internet installations, satellite television, analog video feeds, and closed-circuit television systems. Several types of coaxial cable are used in different applications, with RG6 and RG59 being the most common. RG6 has thicker shielding and is typically used for broadband internet and satellite signals. It supports longer runs and higher frequencies. RG59 is thinner and more flexible, but it is better suited for short analog video connections such as those in legacy security camera systems. Both types use similar construction but differ in their electrical properties and use cases. Two main types of connectors are used with coaxial cable: F-type and BNC. The F-type connector is threaded and used extensively in home cable and internet installations. It connects devices like cable modems and television tuners to coaxial outlets. BNC connectors use a bayonet-style locking mechanism and are more common in professional video equipment, older networking setups, or analog camera feeds. It is important to use the correct connector for the application as they are not interchangeable. Impedance is a key characteristic of coaxial cable. Most coaxial systems are designed for 75 ohms of impedance, which matches the specifications of video and broadband systems. Using cable or connectors with a different impedance rating can lead to signal reflections, loss of quality, and general instability. For this reason, cables and connectors must be matched in both type and specification to ensure reliable performance, especially over longer distances. Coaxial cabling is known for its ability to transmit signals over long distances without significant degradation. It can carry high-frequency signals farther than twisted pair cabling before attenuation becomes a problem. This makes it ideal for television and broadband systems that serve large buildings or long cable runs. However, coaxial cable is bulkier and less flexible than twisted pair, which makes it harder to install in tight or complex environments. Attenuation still occurs over very long runs and may require amplification. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Plenum-rated cable is designed specifically for use in air-handling spaces, such as the space above suspended ceilings or beneath raised floors. These areas are part of the building's HVAC airflow path, which means that materials used there must meet strict fire safety standards. Plenum cable uses low-smoke, flame-retardant insulation that slows the spread of flames and emits fewer toxic fumes if it burns. In many commercial installations, using plenum cable is not optional. It is a requirement dictated by building codes and fire regulations. When comparing plenum-rated, riser-rated, and standard PVC cable jackets, it is important to understand the environment each one is meant for. Riser-rated cable is used in vertical shafts between floors and provides fire resistance, but not the low smoke qualities of plenum. Standard PVC is suitable only for open, non-air handling spaces and is the least fire-resistant of the three. Using a non-compliant jacket in a plenum or riser space can result in failed inspections, legal liability, and increased fire risk. Technicians must confirm jacket type before installation begins. Plenum cable should be used whenever a cable run passes through air ducts or open ceiling spaces used for environmental airflow. This requirement is based on safety standards and not simply a performance recommendation. Technicians cannot substitute PVC or riser cable in these areas, even if the cable length is short. Compliance with fire codes is mandatory and often verified during building inspections. Using the correct cable type protects both infrastructure and occupant safety in the event of a fire. Specialty cables often have identification markings printed directly on the outer jacket. These markings typically include the cable type, such as CM, CMR, or CMP, which stand for communication, riser, and plenum respectively. Other markings may include the manufacturer name, cable category, and performance ratings. These identifiers allow inspectors and technicians to verify that the cable matches the requirements for its installed environment. Label visibility is important, and the markings must remain readable even after the cable has been pulled into place. Plenum-rated cable is more expensive than standard alternatives and can be more difficult to work with. The insulation is stiffer and more resistant to bending, which makes routing the cable through tight spaces more challenging. Installers may need specialized tools for cutting, stripping, or terminating plenum cable. The added complexity increases installation time, but the fire safety benefits and code compliance outweigh these drawbacks in regulated environments. Cost planning should account for the premium associated with plenum materials. Shielding plays a key role in both coaxial and shielded twisted pair cabling. In coaxial cables, shielding is built into the design and surrounds the inner conductor to prevent interference. In shielded twisted pair cables, shielding is applied either to each wire pair or to the cable bundle as a whole. For shielding to be effective, it must be continuous along the cable path and properly grounded. Without grounding, shielded cable can become a source of interference rather than protection. Several factors contribute to signal degradation in all cable types. These include excessive cable length, low-quality connectors, sharp bends, and exposure to electromagnetic interference. Even shielded cables can experience signal loss if installed improperly. Coaxial cables are less prone to crosstalk because of their physical design, but still suffer from attenuation over long distances. Technicians must consider all of these variables during planning, installation, and troubleshooting to ensure optimal performance and reliability. Termination methods differ between coaxial and twisted pair cables. Coaxial cables typically use compression, crimp, or twist-on connectors, such as F-type or BNC. The outer jacket and shielding must be carefully stripped to expose the conductor without damaging the signal path. Twisted pair cables like shielded Ethernet are terminated using RJ45 connectors and often require grounding jacks or patch panels. Proper termination includes maintaining the twist integrity, aligning wires to the correct standard, and ensuring a secure mechanical fit to avoid disconnections. On the exam, candidates may encounter scenarios that test their ability to match cable types to specific environments or identify problems related to improper installation. Questions may include interpreting cable jacket labels, diagnosing interference in shielded cable, or recognizing when a coaxial run exceeds recommended distance. A clear understanding of when and why to use shielded, coaxial, or plenum-rated cable is essential to choose the right solution and ensure network compliance and stability. In summary, shielded twisted pair cables are designed to reduce electromagnetic interference in noisy environments. Coaxial cables provide long-distance signal transmission for video and broadband, and plenum-rated cables ensure fire safety in regulated building spaces. Each cable type has a specific purpose, set of standards, and best practices for installation. On the A+ exam, knowing the differences in structure, use cases, and compliance requirements will help you navigate questions about cable selection, labeling, and proper installation techniques with confidence. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.